Cool. So if you've seen me talk about SQL injection before, I kind of use the same like thing to go introduce SQL injection. So hopefully, like if you've seen it before, I know a couple people I think have like seen me talk about this stuff before. Bear with me because it gets like interesting like towards the end. I'll talk about a problem that uses what we call a blind SQL injection that you may have not seen before. So anyway, the first thing is that if you were here last week, we talked about some client-side attacks. We talked about cross-site scripting particularly. And that's something that executes on the browser. So when you go and you attack, say, Google, you're not really attacking Google. You're attacking the people who are visiting the Google website, as opposed to... I'm not sharing my screen, am I?
We're not.
My bad. Okay, now I am. Okay, so anyway, the server-client model is where we're at right now. So anyway... We talked about how you kind of like, so your client makes a request, the request goes to the server does some processing, and then it constructs a response. And last week we talked about how you can go kind of smuggle things through the request into the response, and sometimes you can see like what we call a reflected cross-site scripting attack. So you're able to go execute a little bit of JavaScript code on somebody else's computer, basically, and like it'll get executed by like Google Chrome or Firefox or whatever. But this time we're going to be talking about how you can actually attack the server itself. And these are going to be a little bit like these are going to be a little more interesting, I think, than the front-end ones. Like the front-end ones have their own like validity, but usually like with the front-end one you can only compromise one person. But when you compromise the server, you've pretty much like compromised anybody who has ever gone to the website and everybody who ever will go to the website. So that's what we're going to talk about. So just to kind of like get on this like same page about what we're talking about here with when we're talking about a backend or a server. We're not actually talking about one thing. Like a lot of the times people's servers and people's backends are going to be a whole like graph of things going together. Like you have the client, which is like going to be like just one computer usually. But then you also have, usually you'll call this an edge node in this graph, is you'll be talking directly to an application engine, and that might be running on PHP. We'll show PHP as the example today, but a lot of these attacks are also applicable for things written in Python, things written in like JavaScript, things written in like all sorts of different languages, because it's like security is pretty like abstracted over the language that you implement things in. So anyway, it could be running on Linux or Windows, it doesn't really matter. You're going to probably see a combination between things running on my Mac and things running on Linux today. But the interesting thing is that the application engine and this server processing is really not the only thing that's going on. You also are talking to a database. And what we're going to find is that although, like, because of firewall rules, we're not going to be able to go talk to the database and exploit the database directly, we're going to be able to go trick the application engine into basically revealing information that we're not supposed to see out of the database. So that's kind of the game here. And so to get started, I'm going to talk a little bit about like HTML and PHP. So you probably, if you were here last week, you saw this slide. But we're going to take this slide and kind of like we were talking last week, we kind of expanded the HTML side of this slide, but this time we're going to expand the PHP side of the slide a little bit. So if you're, just to kind of like go through it real quick again to remind everyone, or also introduce it, you have a little bit of PHP code that gets executed by the server, and when the server prepares its response, when it prepares that HTML, like you don't see any of this PHP anymore. All this PHP just turns into HTML. So like the user at the end of the day is going to see welcome Steven, and then they're going to see the actual year down here in the copyright. They're not going to know what this PHP is. And so that is going to make it a little bit more difficult than when we were doing stuff with HTML, because when we were doing HTML, we had kind of a white box. We were able to go look inside what was happening, but because this PHP is hidden, we have more of a black box that we don't know what's happening in necessarily. So anyway, that's that. And also, you may have noticed that like this PHP is probably not going to be very useful if you actually do it on somebody's application. So we're going to get a little bit more sophisticated with what we're doing in our PHP code. And to start, I'm going to talk a little bit about request verbs. So the way that request verbs work are they're basically ways to go send variables to a server so that it can go process the variable. So this might be your username and password. It might be like if you want to go update your bio or update your profile picture, you can actually attach like files to this as well. Not necessarily a get parameter, but other types of parameters you can attach files to. We're gonna use post parameters today, but I'm gonna show this example of get parameters because we don't really need to go into the whole HTTP protocol today. So anyway, You've probably seen this question mark before at the end of a URL. This question mark basically divides the URL with the parameters. And so here we define two parameters. One of them is name with the value test, and then the other one is the key age with the value 15. And so the way that this works is that if you are writing PHP code, you can, these are both called get parameters. So there's a global variable here called _get, and it's actually a dictionary, and you can go access the, so what the value of name right here would be test, and the value of age would be 15. I'm actually not sure if that's going to be an integer or a string type, but it's all the same. Not really. But anyway, then you can go echo name, and so this will be like, okay, so if you hit this page with this right here, you would see hello welcome test. Is everybody comfortable with that, with the concept of the like get parameter here getting reflected onto the page? Is anybody not comfortable with this idea and you want me to explain it a little more? Because we're gonna add one more layer of intensity to this. There's a question.
Yeah, is the name and age, those both user inputted, or where does that come from?
Yes, so both the name and the way that this would work is that, remember that like all of this code is triggered by a request. So if like they would be undefined if you didn't supply one. These are both instances of user input, and that's actually going to be the key here, is that we're accepting user input. So we're giving another parameter. We're adding like a little bit more complexity, and this is no longer just like a straightforward like deterministic. It's going to go just echo the name of the variable. It's still deterministic, but we're just going to be what we're going to find that's happening is that we're going to be able to give the server like unexpected input that it doesn't know how to handle correctly, or it thinks it knows how to handle correctly, but it actually doesn't do what the developer intended, and we're going to be able to create an exploit doing that. So yes, these
okay, so
yeah, good.
I was just going to say, like, so it get kind of up to the website how those values are inputted. It's just that it then puts it in a URL, which then assigns values to those variables with that PHP code right there. That's not how it works.
Yep, that's exactly how it works. Basically, like PHP under the hood processes the string right here, and it goes and it sticks these values into these global variables.
It's up to the front end to actually put those values there in the URL.
Yes, so yeah, these are part of the request, which comes from the client.
Okay, cool. Okay, cool. All right, thank you.
Yeah, no problem. And I'll show like I'll show an actual demo of this in a couple minutes. So anyway, that's request verbs. So now we're going to get a little bit more sophisticated with what's going on under the hood here, and we're also going to have to introduce something called SQL. So I'll come back to this slide in a second, but basically what's happening here is now we're taking in a username and a password, and these are basically post is just another way you can send a request without it going in the URL. Like you would never want to go put your username and password in the URL here because it might get logged. Whereas if in a post parameter, it goes into the, it's called the request body. And the interesting thing is that HTML forms can do post requests, but it's really hard to go do a post request. Like if you're, it's harder to do a post request. Like you can't just go type something into your Google Chrome address bar and hit enter and be a post request. That's not possible to do. And it's actually a security thing that it's not possible to do that. So anyway, at a high level, what's going on here is that we're getting the username and we're getting the password, and we are creating a new instance of a SQL client. There's a little bit of code missing from here that would actually like go connect to the SQL database. But we go and we send that SQL database a query, and that query is a string. That's going to be the trick here, is that we're able to get, it's a string concatenation of the vulnerability. So we ask the SQL, like, give me all the users where the name is the username and the password is the password, and then we come back and we say if the number of users that came back from the database is greater than 0, we're logged in. If not, if it's 0, then it's gonna not let us in. So that's what's gonna happen at a high level here, and I'm gonna talk a little bit about how SQL works. Give it like a 3-minute like explanation. How many of you are familiar with like some flavor of SQL, like some like table like column structure? Can I get like a 1 in the chat if you know like the difference between like a row and a column on SQL and a 0 if you've never heard of this before? Okay, so yeah, a lot of people are unfamiliar with this, so I'll spend a little extra time on it. So basically, the structure of a SQL database is that one instance of, I'm going to kind of talk about MySQL here specifically, but at the end I'll show a little bit of something with SQLite, and it's all basically the same. The syntax is just a little bit different. So basically what happens here is you have a database, which is like the universe that all your stuff lives in, and inside that database you have a number of tables. And so in this database we have a users table and we have a posts table. And so the users table has a number of columns, just like in Excel spreadsheet. You have columns and you have rows. And so you have a username, a password, and a timestamp that the account was created at here, or the user that was created at here. And then you have, for each of these users, a row that is talking about their username, their password, and the timestamp that they were created at. Usually, if you were doing this, you would want to encrypt the password, but for the sake of this example, I did not encrypt these passwords. So you also have here a second table called posts, and similar to the username and the password columns, there's two text columns here called title and body, and those can be any kind of text that you want. But then posted by here is a special type of column, and the type of this column is a foreign key. So a foreign key just means that you are any row or any cell rather in this table has to go to a user that exists. So if I just put like ABC in here, it wouldn't work. It probably would give me an error. If I set my SQL database up right, it would give me an error. It wouldn't let me go put something in here with an invalid poster. And so that gives you some guarantees on what you're able to guarantee if you're trying to do something. Like if I wanted to go if I was like running a WordPress site or something and I wanted to go show a bunch of posts, and under each of the posts I wanted to go show the author and I wanted to show maybe the author's bio, then I would be the guarantee that the posted by person is in the users table is really important to be able to do that. So anyway, the way that we talk to these databases are with SQL queries. And the really interesting thing about these SQL queries is they're a lot like shell commands in that we usually pass them in strings. Like this language is not like other languages. Like it's not Turing complete, which means you can't emulate any arbitrary language with SQL. But the way that it works is that you say like I'm going to select star. Star means all the columns. So I'm going to get if I were to select all from users, I'm going to get a 3 tuple with the username, the password, and the created at. And I'm going to go take all the values in users, and I'm going to filter basically and say I'm going to filter it only to show me the values where the username is Tilson and the password is this is a bad password. And at a very high level, or at a very simplified level rather, this is how you log into websites. Like some way or another, they're checking your password and they're checking your username against a database, and they're returning information about the user that exists here. And if I had one that was invalid, then it would just return nothing. Does that make sense to everybody? Like kind of the basic idea of SQL here. You don't have to like know any crazy SQL stuff. It's actually really weird. When you're doing security, you know like a very weird subset of SQL commands. You don't have to know anything about like inner joins and like outer joins and all the like crap that you learn in a database class at like Georgia Tech or something. But all you really need to know is like I'll have a whole slide later of a couple like useful SQL tricks. So that's SQL. And the trick here for SQL is, or the next thing that I want to talk about with SQL is the fact that you can go make these queries in PHP. And the way that these queries get made in PHP, there's a way to do it right, but this is the way to do it incorrectly. And oops. So the reason that this is a bad way to do it, actually I won't talk about that yet. I won't talk about why it's a bad way yet. But so basically, notice that look, I really want to hammer down on this line right here, where it's doing SQL query and then this string right here, because this is where like the magic is going to happen, and this is really the most intense part of this code right here. So I kind of talked about what this query does. You're saying select all from users where name is a variable, which is coming from a user input, and password is a variable also coming from the user input. But the thing here is that this query is a string, and name is a string, and password is a string. So all we're doing here is string concatenation. So the fact that I'm just putting a string in right here is allowing me to go put whatever value I sent to the post request into this query directly. So this is like what ends, like this is kind of like pseudocode here, but like if I were to go pass in Tilson and I were to go pass in this is a bad password, then this query is basically gonna reduce down to select all from users where name is Tilson and password this is a bad password. So that's just kind of like hammering in the thing from the prior slide. But what is really fun about this is that, and this is the vulnerability, if I really want to, I can go actually hijack this query and I can exploit the fact that we're using string concatenation here. So let's say instead of saying that my name is Tilson, let's say that my name is Tilson apostrophe or 1 equals 1 semicolon, and then these 2 dashes right here are just a comment in the SQL language. So now what this query reduces to, instead of select all from users where name is Tilson and password this is a bad password, now this query is select all from users where name is Tilson or 1 equals 1, stop. And so that is the vulnerability here, because now if I go and I run a SQL query that says select all from users where name is Tilson or 1 equals 1, well, this where query is always true, so I'm going to be returning like this or here. You know, in an or statement, only one of the things has to be true. So this is actually going to return every single row in the database. And so now, because as long as there is at least one user in the database, the length is going to be greater than 0. It's going to be somewhere between 1 and whatever the maximum storage of your database is. And then it's going to just log you into the database. So that's how that works. Are there any questions about that before I go on to the demo? Does that kind of make sense what just happened here? So basically, like, just to kind of like re-explain it a little bit. Or does anybody have any questions like on Mike first? Feel free to also. Oh, go ahead.
Yeah, I was going to say, so basically what's happening is that the query is making the comment being read, like, so the and password part is being read as a comment?
Yes, exactly. So, yeah, so notice right here is like in my user input, because we didn't check for this in my user input, this gets passed to the SQL query, and SQL doesn't know, like, the difference between, like, all SQL knows is that this is a string. So anything that gets put in that string, it interprets as SQL language. And so because we're basically like this like apostrophe or 1 equals 1 semicolon dash dash is basically hijacking the nature of this query. And so now this query is like this stuff here is getting inputted. And notice how like in the original query, you see how we had that apostrophe after like name? Like I basically, this is my apostrophe from here. And then this is the old apostrophe. And so this 2 dashes right here is basically just saying, like, just ignore anything that the original query was going to have that comes after this. Like, now the query, it's like SQL's not even going to read this. Does that answer your question?
Yeah, thank you.
Cool. So yeah, that's how that works. And you can do the same thing with commands, by the way. Like, I'll just kind of, this is a little bit off topic, but you can do the same thing with commands, and I'll like show you. Oh, I just made like 3 copies of the slide. Command injection works the exact same way. So like instead of doing a SQL query, in PHP it's like it's exec. So we could say like cat like users. This is by the way, this is the same thing as like a plus in Java. In PHP it's a dot. You could just do that, and now like instead of doing like or 1 equals 1, I can say like semicolon cat etc password or any arbitrary file on this computer. That's weird. And now I've just hijacked this command, just like I hijacked the SQL query. So I find that this is a little bit easier to understand than the SQL part, because usually people are more familiar with commands, but it works the exact same way. I'll just leave that there because like it's the same vulnerability in a different clothing. So anyway, I'll show a demo of SQL injection now. I'll stop talking. Okay, so or I'm gonna keep talking. Okay, so this is a website that I made, and I'll show you the database first. So the database name is backendd demo, and I'll also pull up the code here. Yeah, so here's the code. I'll make it a little bigger as well. And that. Okay, so here's the database. database is called backendd demo. The one table in this database is called users. And I can go look at the content of users. And I can just run, by the way, I can run commands here too. This is just the output of select all from users. And there's only one user in this database. Its username is admin. And its password is this is a bad password. Okay, so here's the source code of this website. It just goes and connects to the database. And if there are username and password parameters in the post, then it will go and do the same thing as the code from earlier. Like if there's an error, it'll show you what the error is, but if the rows are more than 0, it'll let you in. So if we go say like test and test here, the query is not going to be true, so it's just going to like show you the form again. But if we say admin, this is a bad password, then it's gonna log us in, and it's also gonna show us the output of this query, which is exactly what we expected it to be. So now let's try something else here. Let's try doing like foo, and then instead of doing our password, we're gonna do that magic query in here, which is like if there's like 5 things in security that you should just like commit to memory, like this is one of those things. Like this is the equivalent to like e to the I pi, or like in like math, or like something like that. Like this is just one of those things that like everybody knows. So anyway, we'll hit login, and now we're in. And remember that we logged in because now we said select username from users. By the way, this is you can just select one of the columns. Like this would be the alternative to putting the asterisk. You can just like select one if you don't need all the information. So select username from users where username is foo, or password is empty, or 1 = 1, stop. And then this is the query, and so it returned true, and the rows, it just returned all the rows in the database. So yeah, so that's my demo here. And I mean, I also have one for this too. So I'll just go ahead and do one, or actually, I'm not going to go into that. I take that back. Okay, so the code for it is on the slide right here. So here's a slide with some useful SQL tricks. I'll talk about substring in a minute, but the other ones are, I mean, I'll tell you why they're in here. Is like, so remember that you need to have a space after the 2 hyphens. Like, I can't tell you how many times this has messed me up. Like, because sometimes if you do this in a get parameter, it will go and it'll like truncate the last space. So you actually might need to go, if you're doing this in a URL, you might need to put a .20 in there. But in general, you just need to go put another space on here because like that is not a comment, but this is a comment. This same deal, like this is just comment everything else. Limit 1. The reason that limit 1 is on here is because a lot of the time what will happen is that instead of saying if response.length is greater than 0, they'll say like response.length equals exactly 1. And so you'll have to add a limit 1 to the end of your query to do that. If you wrap a string in MD5, you get the MD5 hash of it. MD5 it's not a good thing to use. You should be using something that's not MD5 in 2020, but basically MD5 is a one-way function that turns a string into something that's irreversible. Sleep 15 is nice because you can say like, you can just add like you can say like add and sleep 15 onto any query, and then if the page just doesn't respond, if the page just doesn't respond for 15 seconds, that means your SQL query hit and it's working. A lot of the time, they're not going to show you an error if your SQL syntax is messed up. So that's why this is useful, because it's another way to go figure out that your SQL thing is landing. The one that I'll show you later is substring, which you can basically go reverse engineer the value in a cell by saying like and substring 01 is A, or then you can just check all of them. Usually you'd write a script to use this. If that doesn't make sense now, that's okay, because I'm going to go over it in a minute. And then you also have SQL Map, which is a tool that just does all this stuff for you. And you probably could SQL Map the demo, the lab that I'm about to give you, but I would encourage you not to do that, because you're not going to, because SQL Map doesn't work for everything. I've done some CTF problems with like crazy things to try to not allow you to do SQL Map. Like, I had one where there was a website that read OCR from it read text out of an image that you uploaded, and then you had to go do SQL injection in the image text, like embedded in the image. Then I've also done one where like you had you know that pop-up that sometimes come up that asks you for a username and password? Like the SQL injection was in there, so it was really hard to go use SQL map on it. Because SQL map is only really good for get and post parameters. So those are a couple of like my SQL tricks. Now I'm going to give about 10 minutes to, or 10 to 15 minutes for this lab right here. I'll put the link in the thing. This is a SQL injection lab. This is from a high school CTF called Pico CTF. I don't remember which year it's from, but it's a non like trivial amount of points on here. Like it's like I think it was like 300 points on Pico CTF, and it goes from like 10 points to 700. So yeah, so go ahead and try that out. Like you can definitely reference the slides here and see if you can figure out how to solve this. And I'm happy to answer any questions about like SQL injection or about the problem. I'll probably give a hint in like 5 minutes or so. So yeah, good luck. And we'll regroup and I'll talk about how to solve this one, and then I'll show you a more complicated SQL demo. How are y'all doing? Are people still working on it? I just want to make sure that people didn't like fly through it.
Yeah, I'm still working on it.
All right, we got one. Thank you. So I'll give a little hint here. If you go into inspect element, oops, you can see that if you go and kind of go down here into the form, there's an easier way to do this, by the way. You can just click on that. You can see that there is a hidden input here called debug that you can go change that 0 to a 1. Then when you go and you like try to log in, you'll be able to see the query. And remember that your goal here is just to get into the admin account. So the admin account has the username admin. That'll be my hint for you. We'll regroup in probably 5 more minutes, or yeah, 5 more minutes, like 7:43.
Yes.
Alrighty, so how many? Just kind of like get a heuristic here of difficulty of the problems that I'm giving for the labs here. Can I get like a 1 if you were able to get the flag and a 0 if you weren't able to get it? Okay. Cool. So it's like maybe like little less than half. Yeah. So basically, the trick here is that if you try the thing that I told you, you're gonna get it's gonna tell you SQL injection squealy detected. So y'all are gonna dislike how simple this is. There's a couple ways you can do it. I looked up a couple different like solutions to it, and people were able to do it in like various ways. But the easiest way to do this, I think, is to just say, well, you know, the username's admin, and you can just do that, and then comment out the rest of the query, and you got your flag. Because what you did there is like to go. I'll go pull the debug thing back up. I'll show you another trick real quick too.
How did you know that admin would work? I might have missed that.
I think that was just there was just a little bit of guessing on that front. Okay. But I did see another solution to this that somebody was able to come up with, where they were able to just like straight up get around. Or no, never mind. Yeah, but I mean, you got to do a little bit of. You can just do that. Or, no. Yeah, you don't even need the. Yeah, that's interesting that you don't even need the comment. This, by the way, this was also like in the actual like CTF here. There was yeah. So basically, what I did was I just typed admin because that's the username, and then I just like literally commented out the rest of it. So the query became like select all from users where username is admin. Stop. And then it just lets you in. Yeah, one thing that I'll say about this problem is that this is the second in a series of like 4 problems relating to SQL injection, and the username on all of them is admin. So that would have been like one like way to kind of like prime yourself to know that it was admin based on a different thing. But yeah, and I'll show you one more trick here. So one more thing you can do is sometimes it becomes a pain in, like if you, like the debug thing like resets every time you go and you reload this page. So one thing you can do is you can go down into your developer tools on this works in both Chrome and Firefox, by the way. You can go down into your developer tools and you can go to the network tab, and then with the network tab open, if you submit the form, you get the actual request down here that you made, and you see like made a post request to login.php. And like you can see test password debug, and you can go and right click on that and copy it as curl, and then you can go into your terminal here and copy that into your terminal. You don't really need all of this. Like really all you need is I mean if you do that you get, oh, I think I did the wrong. Oh, that was the wrong one. I just flashed my cookie for, I think, Gatherly. Okay, so anyway, this is the one that you're supposed to do, and you get login failed. All you really need here is like the beginning of your curl request, and then you need the data raw parameter here. You can just get login failed, so then you can go turn debug to 1 really easily, and you can just go and like play with your query here. And you can solve the problem the exact same way. You have to escape your. Oops. Maybe you can't do that. Double, maybe? Okay, I'm going to cheat and just change the quotation marks to something else. Ah. Oh, maybe it doesn't like the... There we go. Or no, we didn't, because I made username test. That's funny. Username admin, then you get logged back in. You can just do this in curl. Another thing you can use to do this is this program called Burp Suite, which like gives you a really nice user interface to go edit this this raw data right here. I would, if there was like one thing I could suggest that you do, is use Burp Suite to do this, because it lets you like intercept things, lets you do a bunch of different stuff. So anyway, that's how you do this problem. I'll say like solution, just change the username to admin.
I have a few questions when you get a minute.
Sure, I can take them.
Okay, so I tried entering in for the username admin, then apostrophe or 1 = 1 --, and it didn't let me do that. It said really detected. Why did that not work?
Because this is so basically like the way that the reason is because they were checking for whether there's some kind of check on the back end here that allows them to see if you did that. So like you could probably go and like fudge it and try to like see like does that do it, like see that does it. So maybe you need like a tick or something, and like maybe you can do, you probably can't do this. I don't think you can do that actually. Like you can go play with it. Like I think that the thing that they're checking for is if your string starts with that, and like it's giving you an error because it's actually like breaking the SQL query. It's just not even getting to the squealy injected thing. But like you gotta kind of like play with it a little bit and see if you can get around the filter. Like I mean these problems are made to be broken. So
yeah,
they're like usually there's a way to get around it.
Yeah, I'm pretty sure it's correct syntactically, but
well, the reason it says like SQL like that, like SQL lowercase I, like that's short for SQL injection. So basically, they've built a like filter on here to try to figure out if you're trying to do SQL injection.
Okay.
This is a series, like I said, this is a series of 4 problems, and this is the second problem in the series. And what you were just saying with like literally putting like or 1 = 1 in there would have worked on the first one. That was the solution to the first problem in the series. The names of these problems, by the way, if you want to go check them out, you can go find these on the website, Irish Name Repo. I think it's like 1 through 3 or 1 through 4. That's Irish. This is number 2.
Okay.
But yeah, basically, like you gotta go kind of like try to get around the filter. Is basically the answer to that. Do you have other questions?
Yeah. So. Okay. So you changed the value for something to do with debug from 0 to 1.
Mm-hmm.
How did you know to do that?
So the way that I knew to do that is like usually the first thing that you want to do in one of these problems is go look at the like HTML source code. So from there you can see a couple things. You can see that we're talking to login.php over a post request, and then you also, if you just like see it, you see this hidden form, right? You see this hidden input rather right here. That's called debug, and its value is currently 0. So like a lot of these CTF problems, like if you see something like that, then it's probably you probably need to, or it's probably helpful. Like if you see the word debug in a CTF problem, like usually like the story is that like, oh, the developer forgot to go remove the debug parameter or something. But in this case, like it's literally just something that you want to go like change the 0 to. If you ever see a 0, you just kind of want to change it to a 1. I've actually
just
go ahead.
Messing around and stuff.
Yeah, just messing around with it. Like yeah, like if you don't, if like even if you went to this and you didn't know it was SQL injection, like if you just kind of like a general method for solving these problems is you just want to go like type like garbage characters that look like they might be part of like parsing, like I don't know, just whatever, into the things and see if you can make it give like an error 500. Because if you can get an error 500 like that, that means you found something interesting, and then you can kind of like narrow down and see if you can figure out what it is that's interesting. Is it XSS? Is it like SQL injection? Like what is it? And then you can go, once you've like figure out that it's SQL injection, then the rest of it is just like crafting your payload to work with the website.
This is sounds like a lot of intuition.
Yeah, I mean, like I would say like if you want to do the like the college level like competitions for this is the high school level competition, by the way. But I mean, first off, like you can't really expect to get it in like 10 minutes. Like this is like it would usually take you like that's why it's difficult for me to give like harder problems in here like college level problems, because they usually are going to take a couple hours to go hammer out and figure out everything that's happening. But like if you solve like 20 to 30 of these and like look up the solution after 30 minutes, you'll get pretty good at it. It's like with any kind of problem.
Okay, cool. Well, thank you.
Yeah, no problem. Any other questions? Cool. So there was something else I wanted to say, but I forgot what it was. Anyway, I'll go on to the next demo. So the next demo is doing this thing called blind SQL injection, and basically with like blind SQL injection, this is like I think this was a 750 pointer on the Pico CTF. So basically, like, okay, well, it's actually not that blind because we can see what's happening here. But what we're gonna find is that if you just do your standard like or 1 = 1 thing, it's gonna say you were very close, but it's not gonna give us the answer. However, if you go to view the page source again, you can actually see that we can find the source code here. So we can go ahead and find the source code. By the way, if you see like a .phps thing, like, well, actually my browser does it correctly, but some people like try to go parse, some browsers try to parse this as HTML, it just doesn't look right. But my browser does it correctly. So basically what we have here is that this is kind of a constructed problem. It's not really like a problem you would see in the like on an actual website. Usually things you would see on an actual website are a lot easier than CTF problems. It's kind of like competition math. Like you're never going to have a math problem as difficult as a competition math or a competition programming problem. But anyway, what's happening here is like it's the same old, same old. We go and we make a query. It's vulnerable to SQL injection because of the string. This is actually string interpolation right here. And so it makes a query, gets the responses. It says that the answer has to be equal to a canary for the flag to work. And then if there's a row, then it's going to tell us that we're close. And if it can't find a row, then it's the same thing as like just not letting us in. It's like it's just going to say we're wrong. So basically, so we know it's SQL injection. Like that's like pretty. We got that. But now what we want to do is try to figure out what the canary is. And the way that you figure out what canary is we have to do something called a Boolean-based brute force. So, okay, so the way that like passwords work is that it's hard, you can't just go guess the whole password at once. Like you can't just go try like all like 26 factorial different or shoot like 26 to the 5th power different things to get a 5-character password. But the nice thing is because we have a complex scripting language here, we can do something like this is where the substring thing is going to come in, and I have a cheat sheet here because I'm trying to solve this like relatively quickly. Okay, so what we're going to do is I just pulled up my query for it. I'll pull the source code back up as well. Okay, so we know that we're selecting all from answers where answer is answer, and we're going to actually do a union here. We're going to say, we're going to just completely attach a second query on here because we don't even care about the first query anymore. But we're going to make this like union select answer from answers where answer like A. And, oh, I need to put the thing here. And so it's going to say it's wrong because like is like asking for the prefix of something. We're actually going to use like instead of substring, but like just means like it starts with A. So we could do starts with A, starts with B, starts with C. I'll tell you right now that it's actually, maybe not. Where answer like, well, maybe we should use substring. Substring answer. I gotta look up how to do substring. Okay, so it's gonna be answer 0, 1 equals 4 Maybe it's just not for. That could be the problem too. That's the problem when I try to solve hard problems here. You know, 1 second. I'm going to pull up a write-up so I can see the trick here. You could also just use SQL map to do this, by the way. Like, literally, actually, that's what I'm going to do. I'm just going to run SQL map on this thing, and we're just going to do it the easy way. Okay, so basically SQL map, ooh, I can't even run that. Okay, never mind. We're not going to use SQL map. We're going to have to do it the hard way. I'm very prepared. Okay, so instead of doing union, you can do or answer like for, and that should. Oh, you have to put a. There you go. Okay, the problem was I wasn't putting. Okay, so basically when you do like, you have to go put the put a percent sign at the end of it. That was the problem. Okay, so basically if I go say if answer like 5, it's going to tell me I'm just wrong. But if I say answer like 4, it means it's going to say I'm so close. So basically what we need to do is we need to go try to brute force this, what the actual string is. And so how do I know it's 4? I'll show you. I just know that it's 4 because I've seen the write-up, but I'm going to show you how you can figure out that it's 4. So the way that you would figure out that it's 4 is you would go write a script to go do this for you. So, because like you could go try every single character, but that is probably not the best solution to this. So what I'm going to do is I'm going to go create a Python script to go solve this. And I'm going to see how fast I can do it. Okay. I can't tell you how many things I have on my computer that are all called solve.py. Okay, so anyway, we're going to go... ooh, my computer is being very slow. Let me close out of some things and see if I can make it be faster. Okay, import requests, because we're going to be making some requests here. Import string, because we're going to need that library. That's going to go give us the whole alphabet. Okay, so the URL we know is this. And the way that you would know that this is the URL, by the way, is that you can go view the page source, and you can see that it's a form that goes to this, and so you can go and like try to visit that. And it's a post request actually, or well, apparently it responds to both. But anyway, that's how you know where the URL is. You could also like go look at the network request. Okay, so that's the URL. The alphabet that we're going to be trying to brute force is going to be string. Is that I see that it's 8, by the way, and so if people have to go, I won't be offended. But the recording of this will be up. Okay, so anyway, the password, we don't know what the password is yet, so we're just going to start at none. Put in like a terminating condition there, and we're going to say while not stop. We're going to loop through the entire alphabet here for each character, and we're going to construct the parameters that we want to do. And we know that the parameters are, well, we know the only parameters is answer, so I'm just going to go say, like, answer here. Answer, and the answer is just going to be the query here. So the answer is going to be the payload. And instead of doing for, we're just going to try this certain character here. And, okay, so we're going to make the request. Then if Okay, so you kind of see how this worked here. Like when we found out that it was 4, we saw that it gave us "you're so close," and when we give it something that it's not, like we give it anything else, we just get wrong. So we're just gonna say if so close is in r.text, that means that this character was correct. We actually, my bad, we need to go say password plus C because we're building the password up. And the nice thing is that, like, because at every single character, we can go figure out if we have the password so far. Like, if, like, I'll show you right now that the first 2 characters of this password are 4-1. So now the 4-1 is still going to be correct because we're checking the prefix. So the fact that we have this prefix check is really what is allowing us to go do things, like, better than brute force. Because instead of having if it's like a 10-character password, so instead of having like 26 to the 10, which is this huge number, it's really just 26 times 10, which is 260. So anyway, if so close is in it, password, we're gonna, technically this is inefficient, but we're gonna do this anyway. Don't do this on a coding interview. I'll go ahead and print out password plus C, else if wrong, not in r.text. Oh, elif. Stop is true. Print password. Okay, cool. So if we run that, it's probably not going to work, knowing my luck. This is not the flag. What am I doing wrong here? Maybe instead of doing that, I should do like, yeah. Anybody know Python?
Are you trying to make it into like a list?
Yeah, how do you make that into a list? Isn't it like, oh, you literally just do list.
Yeah. Although that might not split it.
There it goes.
Okay, yeah.
Starting to think I need
There
to
it
use some
goes.
Python.
Okay, I accidentally, okay, so I'm printing password plus C, so it's double counting it, but it'll be right at the end. Oh, I don't want to open news. Yeah, so here comes the flag now. Because I'm just checking the prefix, and then once I find the prefix, then we're using a Boolean-based blind SQL attack to go, basically, like, because we have some kind of indicator that changes on the page whenever we have a correct query. So here's the flag right here. If I go and actually don't need any more of that, it's 41 and 6/6. And that extra S there is just because I'm not a very good programmer. So if we go put that in here, then it still says it's wrong, apparently.
You've been missing other characters.
No. Oh, okay. So the problem is that okay. So when you use like, it's not case sensitive. So actually, we do need to use substring to do this correctly. So it's like substring, or it was substring answer, or now I need an index. Oh boy. Okay. String I plus or let me make sure it's substring. Oh, it's substr. That didn't work. That's probably because I don't know what the. Okay.
I don't know if there's a W in the answer, but you're missing a W in the alphabet.
That was very astute. Thank you. I think that I typed a Q instead. Okay. Okay. So the second parameter is actually should just be 1 because it's the length of the substring, not the size of it. Okay. 1. So okay, substring answer from starting at. Oh, it's 1 indexed. And then it should actually just be C now because we're just looking at the. Ah. Oh. Yeah, see, it usually helps to go just print out code there. Okay, so that shouldn't be there, and that shouldn't be there. SQL syntax is difficult. The weird thing is that it's printing the. It's like printing the password every time. Oh, there's still a syntax error. So,
You have to escape anything in a particular way?
Maybe. Like this I'm looking up a different example of this because I'm trying to figure out where someone else was able to make this thing work. Not in this particular problem, but just like getting like a substring query to work. Oh, maybe I can just use like here. Nope, can't do that. Oh, there's an extra parenthesis right here. Like the just cascading problems here. Okay, now I think it's working. Yeah. Oops. Except I have to save it. And I probably shouldn't be printing the parameters every time anymore. Honestly, like, yeah, I guess this kind of just goes to show that, like, the majority of your time doing these kind of things are just, like, the last, like, 20% of the problem. And then now I think I also have removed the underscore from my search thing here. No, except there wasn't an underscore in it. Oh, because I need the uppercase alphabet now. I've spent an hour because of this like stupid uppercase lowercase thing before. Like this is like during an actual competition. Here it goes.
Are we gonna go over how to automate some of this stuff, different languages, at some point?
Yeah, I'm gonna try to do more of that kind of stuff, like in the weeks like 3 and 4. I think like weeks 3 and 4 are gonna be more like techniques, rather than just like introducing like SQL injection. I'll try to do another like scripting thing, and I'll try to be a little more like prepared on it when I do it, and make sure that I have something that works first. But anyway, here's the password. The problem here was that like did not have a it doesn't respect your things, your capital letters. So anyway, if you type that in, that's the actual answer, and then you got your flag. Cool. It only took an extra 15 minutes. Thank you for the applause. I appreciate that. Okay. So are there any other questions? Yeah, so that's how you do that. And another thing you can do, by the way, is instead of doing that, like sometimes it won't even like do that. You have to just go put like a sleep in there or something. You can say like or like subs. I don't know if this is gonna work, but and sleep 5. And so now if it sleeps for 5 seconds, then that is what you want. Those are a real pain in the ass because you never know if it's the... I'll put a solution to this, by the way, on the slides. The sleep ones are a pain in the ass because you have to like make it... You either have to make it long enough so that you're able to like see it, and then you just have to take a while to go solve your problem, or you have to go figure out like, well, is it just the server being slow because there's 1,000 other people trying to do this exact same attack right now, or is it my payload making it slow? And it's kind of a pain. So I'm going to say solution. Oops. And I'll put that in there if people want to go check it out. This is, by the way, an adaptation of somebody else's solution because their thing, it was great because the write-up that I found just said they go do the like thing and then they go say, turns out the query wasn't case sensitive and the answer that we're looking for is, and then they just go tell you the one with the capital letters in it. So that's not very helpful. A lot of the time in the, like, some of the times in the CTFs, especially like the one-day CTFs, they'll just kind of, if you go tell them that you have something that you think is an answer, they'll like tell you that you're on the right track, so you realize that you're not crazy, which is pretty helpful. But I mean, at the end of the day, that's kind of part of the problem that you have to go deal with that. So, solution. Okay, so I'm gonna stop sharing. I'm gonna stop the recording.